Professor Dave again. Let's learn about asymptotes.
He knows a lot about all kinds of stuff. Professor Dave explains.
We just learned how to graph higher degree polynomials, but we also need to graph rational functions. These are functions that are expressed as quotients of polynomial functions. This can make things a bit trickier for a number of reasons. First, it's not as immediately apparent what the behavior of the function will be. And second, the domain will typically not be all real numbers, as it was for polynomials. This is because the denominator of the fraction can't be 0, and any value for x that produces 0 for one of these terms will therefore not be present in the domain of the function. Let's learn how to graph these kinds of functions, starting with the simplest, 1 over x. Immediately, we know that x can't equal 0, so 0 is not part of the domain of this function. But what happens on either side of x equals 0? Well, let's plug in some numbers. -1 gives us -1, so -1, -1 is part of the function. As we go left, we get closer and closer to 0 from the negative direction, with the limit of reaching 0 as x approaches -infinity. So the function approaches 0, but never quite gets there when we go left. In this tiny interval from -1 to 0, we can see that plugging in fractions of -1 will give us very big negative numbers that decrease rapidly, heading towards -infinity as x approaches 0. So that will look like this. On the positive side, we get something similar. Plugging in 1, we can see that 1, 1 is part of the function. Then with bigger numbers, we get closer and closer to 0, so that gives us this behavior, approaching 0 as x gets infinitely large. And plugging in fractions of 1, it brings the function closer and closer to infinity as x approaches 0, so that will look like this. What we can say about this function is that it has two asymptotes that can be represented by x equals 0 and y equals 0. These are lines that the function approaches, getting closer and closer, but never quite touching. Asymptotes can be vertical, horizontal, or at an angle, and finding these will be the key to graphing rational functions. So let's learn how to find them. Finding vertical asymptotes is pretty simple, as these are values that are not in the domain of the function. That means that these are the zeros of the denominator. Take something like x over x squared minus 9. We know that this denominator can be factored to get x plus 3 times x minus 3, and that means that 3 and -3 are the two zeros of the denominator. Since those values are not in the domain of the function, we must have vertical asymptotes at x equals -3 and x equals 3. We can also find out if there is a horizontal asymptote. We should note that while there can be multiple vertical asymptotes, there can only be one horizontal asymptote at most, so it's either 1 or none. To find out which, we list the numerator and denominator of the function as polynomials in standard form, not as products of factors. Then we look at the leading terms. If the denominator is a higher degree polynomial than the numerator, y equals 0 will be an asymptote. If the numerator is a higher degree polynomial than the denominator, there will be no horizontal asymptote. If the two polynomials are of the same degree, then we take the leading coefficient of the top over the leading coefficient of the bottom, and y equals that number will be the horizontal asymptote. In this case, the denominator is of a higher degree as it is a quadratic, so y equals 0 is the asymptote. Then to graph the function, we can test selective values of y to find the behavior of the function as it approaches these asymptotes from either side. So we pick some near the vertical asymptotes and some points as the function approaches positive and negative infinity. A quick test of 5 or 6 points will reveal the following behavior for the function. Let's take note that a function can sometimes cross an asymptote, the way this function crosses the horizontal asymptote in the middle section. functions. We can find vertical asymptotes by finding the zeros of the denominator. We can see if there is a horizontal asymptote by looking at the degree of the polynomials on the top and bottom, as well as the coefficients of their leading terms. We can always find x and y intercepts to help us sketch, and then selectively picking other points to plot will help reveal the behavior of the function as it approaches an asymptote. With all of this information, it should be relatively easy to graph rational functions with all real roots. So let's check comprehension.
Step 1, we need to find the zero of denominator. So based on this question, x plus 4 equal to 0. So we get that x is equal to -4. After we get the zero of denominator, we need to evaluate the two-sided limits. This is one to determine whether we can obtain the infinite limit based on the definition of vertical asymptote. So let us start from the left-hand side limit. So when the limit approaches -4 from left, so the ratio we get there is a constant over 0. So from the left, so it's a 0 minus, so the overall ratio is a positive infinity. So when it comes to the right-hand side limit, we also get that it's a constant number over 0, but it's a negative over 0 plus, so the overall is a negative infinity. So after we evaluate the limit, we need to draw conclusion based on the definition. As long as we get the infinite limit, so we can draw conclusion x equal to -4 is vertical asymptote. So how about the horizontal asymptote? So we will evaluate the limit at infinity. So the domain is a real number except the denominator, so we have two-sided. So first, we found that when approaches to positive infinity, we get the indeterminate form. So as usual, and recall back from the previous lesson, we need to divide the highest degree from the denominator. So from here, the highest degree is a positive 1, linear. So we multiply with 1 over x. After we simplify and direct substitution, we get a constant number, positive 2. So when approaches to negative infinity, we also get the same solution as a positive 2. So at last, the conclusion, we will say that y equal to 2 is horizontal asymptote. Okay guys, so do not forget about, if you want to find the asymptote, you have to follow the definition of vertical and horizontal asymptote. Thank you for watching. See you, bye.